Everyone, I wanted to focus on today on the visual pathway system. So let me get my pointer out. And if you don't know this already, the eyes are in charge of visual sensory. It's a visual sensory organ. So as light comes in, all the eyes are doing is just recording. The eyes are not in charge of making any decisions whatsoever. So as they come in, interesting enough, it's not technically this easy, or this version is not 100% correct, but you should get the gist. Most of what you see from the right-hand side comes in and crosses over. So there's actually a little X right here called the optic chiasma. So what you see on the right gets processed on the left and vice versa. So then it gets processed in the occipital lobe. Okay, so I want to also go to the next part. So again, as we move forward throughout the brain, as the brain is processing the visual stimulus, it's the different parts of the brain that help bring the picture to life. So this notion that we only use an X% of our brain is an old wives' tale. We use all of our brain most of the time, but especially through vision. Okay, so and then as we move forward, we're going to start seeing colors start coming into fruition. Our brain actually paints a picture of what's happening. And then we start seeing objects and faces moving forward. And then we start processing the motion. So again, remember the eyes are just like a video recorder. That's all they're doing. They're just letting light in. It's the brain that is actually the microprocessor and actually making sense of the world around you. Crazy enough, what you see gets crossed. What actually goes into the eyeball, since the lens actually gets flipped. So the picture actually gets flipped in the brain, and then your brain has to reflip it. Crazy, isn't it? All right, so let's move on to playing the next simulation here. So what happens when we start turning off certain aspects of the brain, or they're not working entirely properly? So for example, maybe your ear, the different parts of your ear is working just fine, but if the brain, remember, if is not working, the brain is not working, it's like the computer. If the computer's not working, you're not going to be able to process. Just because the microphone is working, again, if the brain is damaged, you're not going to be able to process what information is coming in. Okay, so let's see what happens here. Okay. Well, I hope you guys could hear that on your end. So let's start taking, I turned off the right side vision. Remember, everything gets crisscrossed. So if I turn off the left back occipital region, that means I'm going to start limiting. I'm going to start limiting the visual field on the right. So what happens if I start limiting the right? Let me start limiting the left motion. Let's see what happens here. I'm like flying blind here. So let me do one at a time. All right, so let's do right motion. Okay. What about hearing? Again, no volume. What about language? Okay, it's not processing the language. What about right peripheral? Okay, so the periphery is having difficulty. And Let's see what happens with left vision. Oh my gosh, right peripheral and left vision completely out. You're toast in terms of trying to see what's going on around you. Now, how do we know that certain aspects of the brain are in charge of specific functions? Now, they are all working together in some degree, but certain aspects seem to have specific roles of the brain. So, for example, the occipital lobe, mainly in charge of vision, processing vision. Well, before modern medicine, the way people discovered that was due to just extreme injuries. Let's just say that. Uh, let's just say that. To put it lightly, extreme injuries. So people would get impaled in certain aspects of their brain, and then whether their behavior or vision or hearing subsided, that's how they figured out. The scientists figured out initially, just due to human injuries. As we move forward, we're obviously not going to injure or deactivate a human brain. Or certain aspects of the brain, we're going to use functional magnetic resonance imaging, also known as fMRI. So it's just like an MRI machine, but instead of it's gonna focus on certain aspects of the brain. So that's how they're seeing pictures light up on certain aspects of the brain. So I hope you guys enjoyed the structure, function, and different pathways of the brain. Cheers.